In this section, you're looking at optimization problems, which will normally involve finding the minimum or maximum value of a function that you determine for the optimization. Obviously, depending on whether you're wanting to maximize something or minimize something. In this case, we're referencing example 2 in the commentary, which is problem 20 on page 217 of your textbook. In this problem, you're wanting to maximize the volume of the box based on the height x. You determine an equation in part B, and in part C you use that equation to find the maximum value of that equation. And you can verify this using your calculator. The first step is to put the equation into the y equals menu. So under y1, let's put that equation from part B, which is 4 times 144x minus 24x squared plus x cubed. To enter in the x cubed, it's simply x caret 3. Now if you use the standard window, you won't see much. It's because other than when x is 0, nothing else is really on this graph. We need to change the parameters. Now the equation that we determined in part B limits the value of x from 0 to 12 in an open interval. Obviously if the height is 0, you won't have a box. If the height is 12, again, you end up with a volume of 0. So we need to change the parameters. Let's change our x minimum to 0. Let's change our x maximum to 12. And then we need to change the y minimum and maximum as well. If you change the y minimum to 0, because that would be the volume if x were 0 or 12. And then in part C we determined that the maximum volume would be 1024, so let's go ahead and make the y max somewhere near that. Let's say 1100. Now go back to the graph and you should see that volume function. Now what we're wanting to verify is that this value up here, where the maximum is 1024. Now to have your calculator determine that for you, go to Second, Calc, and if you look at options 3 and 4, it's minimum and maximum. If you were optimizing according to a minimum, you would use 3, and in this case, since we're maximizing the volume, we want option 4. You should be familiar with this at this point. It's going to ask for a left bound. So the first step is, let's go to the left of the maximum. Hit enter. Now let's go to the right of the maximum. And how you can tell when y starts going back down. So it's going back down, so let's hit enter again. And then you can just move back towards the maximum. Hit enter when it asks for guess. And you get that at x equals 3.999984, y equals 1024. And again, with your calculator, when it's this close, you can normally assume that it's just 4. To verify that, you could go to Second, Calc, and use the value function again. And x equals 4, y equals 1024. So that verifies the maximum value of the volume that you found according to the volume function. And once again, if you wanted to find the minimum, if it was a function that was minimizing something such as cost, you would just go to minimum instead of maximum, and then follow the same procedure. Left bound on the left of the minimum, right bound on the right, so on and so forth. And that's it.